Hi, folks. Welcome to this first video for chapter 5. And in this chapter, we're going to actually just take a look at two examples that are very similar to your homework questions on the MyOpenMath, okay? We're going to start in this video with question number 2, okay? And we'll talk through it. And if you are still having questions, I think that section 5.2 in your textbook is a really good one to go back to. All right, so if we're feeling kind of stuck, going back to section 5.2 in your textbook will be really helpful. All right, so let's take a look at question number 2. It says, today the waves are crashing onto the beach every 5.3 seconds. The time from when a person arrives at the shoreline until a crashing wave is observed follows a uniform distribution from 0 to 5.3 seconds. Round to 4 decimal places where possible. I'm just going to pause for a moment before we go into the question and look at this last statement here, round to 4 decimal places whenever possible. I know that some of us are getting that you told me you're getting answers that are really close, but it's still telling you you're wrong. And unfortunately, this program does care how you round, okay? So that's going to be sort of a secondary thing that I'm going to talk about as I'm going through the content for today. Okay, so let's take a look at this. When we're looking at uniform distribution, there's a few things that we actually want to know. And in particular, we really want to know sort of like where we're starting, and we call that the A, and where we're ending, and that's our B. Okay, so our time here is starting at 0 seconds and ending at 5.3 seconds. And that would be important for us, okay? All right, so let's take a look at part A. The mean of this distribution is, and so in your book, we see that the mean, that letter mu, is equal to A plus B over 2, okay? And so in our case, all we're gonna do now that we figured out our A and figured out our B, we're just gonna plug those numbers right in. 0 plus 5.3 divided by 2. And when we type that into the calculator, we get 2.65. And there's only 2 decimals, so you just put all of those values in. Okay, so 2.65 is what will go into the box. And if you click OK, or if you click submit, it should give you an A-OK on that answer. Okay. All right, the standard deviation is, and again, in our book, we have this formula, this sigma for standard deviation equals the square root of b minus a squared over 12, okay? So it sort of depends what your a and b are, but it'll always be squared, it'll always be over 12, and then we will always take the square root, okay? And so when I plug in the numbers here, I'm going to get 5.3 minus 0 squared over 12. And when I type this into the calculator, I'm going to get 1.52997 and a bunch of other numbers, okay? And so here's where I want to talk about the rounding. Let's say that you're like, well, I'm going to round to 4 decimal places, and so I'll get 1.5299. And you type that in, and it tells you that you're incorrect. I can see how you would be super frustrated by this, okay? But the issue here is that you didn't round to 4 decimal places, all right? So let me erase this. And if we're rounding to 4 decimal places here, all right, what we really want to do is say after this decimal place, if the 5th decimal place is bigger than 5, now we're going to round up, okay? That's going to turn, oops, that's going to turn this into a 0, which is also going to turn this one into a 0. And at the end of the day, we're going to end up with 1.53. Okay? Only in this case. So it's not always going to round like this, but because we're so close to this like 0.99 here, that rounds it up all the way to 1.53. Okay? So sometimes we might see rounding situations like that. All right. So in part C, it says the probability that wave will crash onto the beach exactly 4 seconds after the person arrives is, okay? And so I want to remind us here what a uniform distribution is, right? If we think about a picture. So if we're thinking about a picture, a uniform distribution, okay, is always going to be some sort of rectangle. And we're going to have x across the x-axis. And we always actually put like our A and our B on our x-axis, okay? And so let me change colors here. We've got A equals 0, and in this case, B equals 5.3, okay? And so what we have here, we'll end up having a uniform distribution, meaning it'll be flat at the top. And so when we're looking at uniform distribution, we're really looking at areas of rectangles, okay? And so as a reminder, the area of any rectangle is your length times your height, okay? Your length times your height, or your width times your height. Doesn't really matter how you say it, but we're basically just going to be looking at sort of like this times this, okay? All right, let me get rid of those. All right, so now the probability that a wave will crash onto the beach in exactly 4.6 seconds, well, that's going to correspond to the skinniest rectangle there ever was that was just at 4.6 seconds. Okay, now it's so skinny, in fact, that at 4.6 seconds, we actually just have a line. And this line has no area, it has an area of 0. And so it turns out that for any uniform distribution, if we're looking for the probability at a very specific time, that is always going to be 0. Okay. All right. So let's take a look at part D. The probability that the wave will crash onto the beach between 0.5 and 2.1 seconds after the person arrives. All right, so let me get rid of this part of our diagram. Oops. And put that x-axis back in. Great. Okay, so let's draw this. Where would we draw the lines if we had 0.5 to 2.1? And it turns out that we would draw one like here. So this would be 0.5 and 2.1 is maybe about here. Okay. And so what we're trying to find here is what's the area of this blue rectangle. Okay. Now, I know that the length of this rectangle, right? So let's say the length of this rectangle is just 2.1 minus 0.5, which is 1.6, okay? But what I don't know is how tall is that rectangle, okay? In other words, I don't know this piece, the height of the rectangle. And so what I'm going to do is I'm going to use our formula to help us find the height, okay? And so the formula that we use to find the height, okay, that's going to be 1 over b minus a. And we do 1 over 5.3 minus 0. And I'm actually just going to leave it as 1 over 5.3, okay? Because the more that you round in these kinds of questions, the more that you round, the more likely you are to get the question wrong because you rounded along the way. Okay, so I'm just going to leave the height as 1 over 5.3. Okay, so now to find the area of this, I'm going to take the length, I'm going to times it by the height, and I'm going to see what I get. In other words, I have 1.6 times 1 over 5.3 0.3. And when I type that into the calculator, I get 0.30188. Now, I know that we only want to round to 4 decimal places. And so since the number after that blue line is an 8, I'm actually going to round this 8 up to a 9. Okay. So in other words, I get 0.3019. Okay. So we're really just looking for areas of rectangles. Okay, let's take a look at E. The probability that it will take longer than 3.86 seconds for the wave to crash onto the beach after a person arrives. Okay, so same kind of idea. Let's change to a different color. Let's do green for this one. Okay, so this is our green rectangle. This one was our blue rectangle on the page. Okay, but with this green rectangle, it's taking longer than 3.86. And so we know that we're looking for the area of this green rectangle. Okay, and so I need to find my length. I already know my height, and so the length for this green rectangle is going to be 5.3 minus 3.86. And let me grab a calculator and see what that is. 5.3 minus 3.86 is going to give you 1.44. Okay. And so my work here will be 1.44 times 1 over 5.3. And when I type that in, I will get 0.27169. I know that I only want to round to 4 decimal places, so I'm going to type in 0.2717 because the 9 means I need to round up. Okay, so 0.2717. Okay. Now, I know we've done a lot so far, but really the first 2 questions were just formulas. That'll be the same formula every time. C was a super important concept, and D and E were just practicing finding the area of rectangles. Okay. So let's move along. We've got 3 parts left. Okay. So F says, suppose that the person has already been standing at the shoreline for 0.6 seconds without a wave crashing in. Find the probability that it will take between 2.1 and 2.4 seconds for the wave to crash onto the shoreline. And so what we have here is we actually have a case of conditional probability. And what I mean by that is that we need 2 things to happen. First, someone has been waiting for 0.6 seconds and no wave has happened. And then second, we want to find the probability that a wave will actually crash between 2.1 and 2.4 seconds. Okay. And so what we need to do in a case like this is we actually need to redraw our rectangle. And so instead of having the rectangle start at 0 and go to 5.3, like I did in the beginning, my rectangle is now going to start at 0.6 and go to 5.3. Okay, and so that 0.6 that I have right here, that's because I'm waiting 0.6 seconds. And same thing, I'm going to draw not a triangle, I'm going to draw a rectangle here. Okay, and it turns out that the height of this rectangle, I can find the same way as the other ones. The height is going to be 1 over b minus a, which is now 1 over 5.3 minus 0.6, which is 1 over 4.7. Okay, now you can turn it into a decimal if you want, but again, the more you round, the harder it is to get the right answer in the MyOpenMath. Okay, so we've got the height of this rectangle, and now we want to find the probability that, let's go with a purple one this time, between 2.1 and 2.4. So we want to know the area of that rectangle. Okay, and so that is going to be 2.4 minus 2.1. That'll give me the length times the height, which is 1 over 4.7. I type this all into my calculator and I get 0.06382. And if I think about rounding here, okay, I'm going to find that that 2 means I keep the 8 the way it is. In other words, I have a area of 0.0638. Okay, so same idea of area, but now we just have a different size rectangle, like a different length along the bottom, okay? All right, part G. Part G says 71% of the time, a person will wait at least how long before the waves crash in? All right, so this is saying we know that our rectangle has a height of 1 over 5.3, okay? This is the height. What we don't know is the length of this rectangle, but we know that the area is 1 minus 0.71. Okay. And when we do that, we'll get 1 over 5.3 times the length that we don't know equals 0.29. And if I multiply both sides by 5.3, I get a length of 1.537. Okay. And so what that means is the average, or 71% of the time, people will wait about 1.537 seconds before a wave crashes in. All right, last question here. Find the minimum for the upper quartile. And so the upper quartile, that is the 75th percentile. Okay. And so what that means is that we have our 1 over 5.3, that's our height, times our length, again, we don't know what that is yet, equals 0.75. Okay, we want to know what area gives us 75% of this whole, of 75% of that area. And so when we multiply that 5.3 across, we'll end up with 3.975 seconds. Okay. All right, let me get this all on one screen for you. But hopefully this was helpful in terms of looking at one of the homework problems step by step. But if you have any questions, let me know and I'd be happy to help you out.